The universe is vast beyond comprehension, 13.8 billion years old and filled with trillions of galaxies. Each one holds billions of stars, many of them warming alien worlds, right now as you sit there, listening. In our own Milky Way, there could be tens of billions of planets capable of hosting life. When you look at the math, it feels impossible that we're alone. Surely, someone out there has gone further, turned stars into batteries, while we're still figuring out how to change our cars. But before we go looking for our cosmic neighbors or potential enemies, there's a question we need to answer. How do we measure a civilization that might see Earth the same way we see a campfire? Because if we want to find them, we need to understand what we're even looking for. In an observable universe filled with up to 2 trillion galaxies, made up of something like 20,000 billion stars, it's hard to imagine we're alone. Scientists assume there are some 40 billion Earth-like planets just in our Milky Way. When we look at these numbers, the idea that nobody else is out there seems almost absurd. But here's the thing, we have a problem. What exactly are we looking for? In a universe this big and old, civilizations might start millions of years apart from each other, developing in completely different directions and speeds. So, we're not just looking across distances of dozens to hundreds of thousands of light years, we're looking for anything from cavemen to being so advanced they might as well be gods. We need a framework to think better thoughts that help us search better. In 1964, Soviet astronomer Nikolai Kardashev developed a method of categorizing civilizations from cave dwellers all the way to gods ruling over galaxies. His insight was brilliant in its simplicity. If aliens have to follow the same laws of physics we do, then there's a measurable metric for progress: energy use. Think about it. Human progress can be measured very precisely by how much energy we've extracted from our environment and how we've made it usable. We started with muscles until we learned to control fire. Then we made machines that used kinetic energy from water and wind. As our machines got better, we began to harness concentrated energy from dead plants we dug up from the ground. Between 1800 and 2015, our population increased sevenfold, while humanity consumed 25 times more energy. As our energy consumption grew exponentially, so did our abilities. The Kardashev Scale ranks civilizations by their energy use, and it's been refined over the decades into 4 main categories that differ by orders of magnitude. It's like comparing an ant colony to a human metropolitan area. To ants, we're so complex and powerful, we might as well be gods. A Type 1 civilization can use all the available energy of their home planet. They've mastered their world completely. Today, humanity ranks at about 0.75 on that scale. We've altered our planet, created huge structures, mined and stripped mountains, removed rainforests, and drained swamps. We've created rivers and lakes and changed the composition and temperature of the atmosphere. If progress continues and we don't make Earth uninhabitable, we'll become a full Type 1 civilization in just the next few hundred years. We're getting there, but we're not quite there yet. Any civilization that becomes Type 1 is bound to look outside. If they're still curious, competitive, and expansionist, the next step is trying to alter and mine other planets and bodies. This might start with outposts in space, transition to infrastructure and industries near the home planet, move on to colonies, and end with terraforming other planets by changing their atmosphere, rotation, or position. As a civilization expands and uses more stuff and space, its energy composition scales with them. At some point, they may embark on the largest project a Type 2 civilization can take on, harnessing the energy of their star by building a Dyson swarm. A Dyson swarm isn't a solid shell around a star, it's a collection of satellites, solar collectors, and habitats that capture the star's energy. Once this megastructure is finished, energy becomes practically unlimited for molding the home system however they see fit. If they're still curious, competitive, and expansionist, and now have complete control over their home system, with stellar infrastructure in place and the energy output of a star, the next frontier moves to other stars light years away. For a Type 2 civilization, the distance to other stars might feel like the distance between Earth and Pluto does to us today. technically within reach, but only with immense investments in terms of time, ingenuity, and resources. This begins their transition toward a Type 3, a civilization able to use the available energy of their entire galaxy. This step is so far beyond us that it becomes hard to imagine what exactly these challenges will look like. Will they find solutions to the vast distances and travel times of hundreds or thousands of years? Will they communicate and keep a shared culture between colonies light years ahead? Or will they split into separate Type 2 civilizations, maybe even different species? The closer a species gets to Type 3, the harder it becomes to fathom what it might actually look like. They might discover new physics, understand and control dark matter and energy, or travel faster than light. We might be unable to grasp their motives, technology, and actions as of yet. Some scientists suggest there might be Type 4 and Type 5 civilizations, whose influence stretches over galaxy clusters or superclusters, structures comprising thousands of galaxies and trillions of stars. A Type 4 civilization, it would harness the energy of entire galaxy clusters, like the Virgo supercluster, which contains over 1,300 galaxies, including our own Milky Way. They'd be engineering on scales that span 110 million light-years, potentially manipulating dark matter and dark energy, the mysterious forces that make up 95% of our universe. Type 5 civilizations, they would operate multiple superclusters, controlling energy equivalent to roughly 10 to the power of 41 watts. To put that into perspective, that's 1 trillion times more energy than our entire observable universe currently produces through stellar fusion. They might be capable of creating and destroying galaxies at will, or even manipulating the fundamental constants of physics. At the theoretical peak sits the Type Omega civilization, masters of the multiverse itself. They wouldn't just manipulate our universe, they'd create new ones, possibly with different physical laws entirely. Think of them as cosmic architects, building realities like we build sandcastles. Some physicists speculate these beings might exist outside our normal space-time, viewing entire universes as temporary experiments. Maybe they were just bored. Here's where this thought experiment gets really interesting. If our ideas about interstellar civilizations are correct, then we can be pretty sure there are no Type 3 civilizations and beyond near the Milky Way. Their influence would be so all-encompassing, and their technology so far above our own that we couldn't miss them. The galaxy should flash with their activity in thousands of star systems. We should be able to see their artifacts or movements between different parts of their empire. Even if a Type 3 civilization existed in the past and died a mysterious death, we should detect remnants of their empire. But when scientists looked, they didn't find remnants of harvested stars, decaying megastructures, or scars of great interstellar wars. So they're very likely not out there and never were. In a sense, this is sad, but it's also reassuring. It leaves the galaxy to us and others similar to us. The most promising civilizations to look for, they might be somewhere in the spectrum from a Type 1.5 to a Type 2.5. They wouldn't be too advanced to understand, and their motives might be comprehensible to us. They may have finished their first megastructures and might be in the process of moving between stars, transmitting enormous amounts of information into space, by accident or on purpose. They would probably also look to the stars and look for others, just like us. On an interstellar scale, humanity is practically invisible. Our signals may extend over an impressive 200 light-years, but this is only a tiny fraction of the Milky Way. Even if someone were listening, after a few light-years our signals decay into noise, impossible to identify as the source of an intelligent species. A civilization might be as close as our nearest stellar neighbor, the Alpha Centauri system, and we'd have no way of realizing they exist unless they're actively transmitting radio signals into space. A high Type 2 civilization, it might already consider humanity too primitive to even talk to. A Type 3 civilization might feel about us like we feel about bacteria living on an anthill. Maybe they wouldn't even consider us conscious or our survival relevant. But we can only pray that they're nice gods. As flawed as this classification may be, this thought experiment tells us interesting things about our place in the universe. We're cosmic toddlers, barely able to harness our planet's energy. while somewhere out there might be a civilization that treats galaxies like we treat city blocks. The scale forces us to confront a humbling truth. We're not special because we're advanced, we're special because we're conscious, curious, and looking outward. We're taking our first steps on a ladder that stretches to infinity. The Kardashev Scale isn't just about measuring alien civilizations, it's about understanding our own potential and limitations. We're living in a universe where beings might casually rearrange solar systems while we're still figuring out renewable energy. But maybe that's exactly where we need to be right now. Every Type 3 civilization, it started somewhere, probably a lot like us, curious creatures looking up to the stars and wondering who else is out there. The universe is vast, ancient, and full of possibilities, and maybe, just maybe, we're not as alone as we think. We've only just started looking. And if you want to find more, don't forget to like and subscribe.